Looks like next up we have a lady that says her heat's working just fine overnight. However, as the temperature got a little warmer today, she turned the air conditioning on and the temperature is still going up. It says she has it set for 68 and it's 70 inside and still going up a little bit. The outdoor temperature, just to give you an idea, looks to be about 75 today. So we'll stop by and see what's going on.
So that's what it's been. It was 69 in here when I turned it on. So that's what it's been doing. It's been going up instead of down.
So coming out here, we can hear this thing's making a terrible sound. We're going to go ahead and unplug this guy. But you can see our fan is trying to spin, but it is very, very hot to the touch. Honestly, as loud as this motor was, it was trying to spin a little bit. So we're looking at most likely stuck bearings, so a bad motor. But we'll go ahead and do a little troubleshooting. Since we're here, we'll put our meter in continuity, so we know if we have any kind of electrical connection that's almost a direct short. We'll hear the beep. So our fan motor's common is connected here, going to our fan, and our other leg of our fan is coming back and attached to this relay. Our relay is attached to the opposite side of our contactor. So if our relay is supplying power to our fan, we should hear continuity there, which we do. So we know our relay is good. The other thing we would look for is to see whether our capacitor was good over here. So we have this guy still set into capacitance, and we'll check this. We're looking for about 5, so we've got 4.99. So we know our capacitor is good. Because of the terrible noises this thing was making, most likely the bearings are out on it. That does spin, but that is, you can see how quickly it's kind of slowing down. Basically the bearings on this motor are going out, is what it amounts to. So we'll try to get her a new motor and get her taken care of directly.
He says, come on board for Hvac ride-alongs. Hvac ride-alongs, where the wires meet the frame. Fixing up the systems, ain't no two jobs the same. Turn around, check the flow. Learn where you belong and find your spark on Hvac ride-alongs. He's got tales of compressors and coils that can hum. How to patch a leaky system, diagnose on the run. Changing filters like clockwork, pushing dust where it's gone. He shouts, hey, let's roll.
Luckily for that particular homeowner, the fan motor is in fact still under the manufacturer's parts warranty. So we've got one ordered. Unluckily for them, it does have a few days lead time before it arrives. So we'll get back over there when we have the motor in hand and get them taken care of.
Tales of compressors and coils that can hum. How to patch a leaky system, diagnose on the run. Changing filters like clockwork, pushing dust where it's gone. He shouts, hey, let's roll. It's HV ride-alongs. In the crawl space is tight, on rooftops where we stray. He swears by his craft and his wisdom leads the way. Even when it's boiling, all the winds are strong. He'll say this is the life. Hvac ride-alongs. In the crawl space is tight, on rooftops where we stray. He swears by his craft and his wisdom leads the way. Even when it's boiling, all the winds are strong. He say this is the life. HV ride-alongs.
It's not always the case, but in this particular one, this is the OEM motor for warranty replacement. So we know that our wiring colors do match up with these same wiring colors from the previous motor, and they do match up with our wiring diagram. So we know that our black wire here connects to L1, going to our fan relay to supply power to our motor. Our yellow wires are common from our fan motor. Attaches to L2, which can either come directly off the contactor or since it's just jumped across to the common side of our capacitor. I believe on our diagram it does show that our L2 for our motor, common for our motor, comes from the common side of the capacitor, so we'll just put it back the way we found it. But electrically, either or is fine. Our brown wire goes to our start windings on our motor, and we hook it to the 5 MFD or fan. I don't know if we can see it in there, or our fan side of our dual capacitor. So now we're all bolted in, wired up, and ready to confirm operation on this guy. And now just to confirm operation. There we go. Sounds happy. Just amp this fellow out. 1.1, 1.11 amps. Nameplate data. Looks like we're looking for 1.4 as full load amperage, so we're well within our limits. So we are done. All in all, not a bad service call. The worst part was waiting for the warranty motor to show up. Being that it was an OEM motor, it did make our lives a little easier, as the wiring exactly matched up with the motor we took off, and wiring colors all matched up to what was in our wiring diagram. Didn't have to worry about sawing down a motor shaft or having to reverse the motor, so just literally a plug and play adventure. Do keep in mind, a lot of times our whole point is manipulating the boiling point of a refrigerant to cause either cooling or heating. So if we don't have any airflow over one of our coils, we're not going to hit that liquid or vapor saturation point, and we're just not going to completely work correctly. So a lot of times everyone wants to jump to, hey, it's got to be a refrigerant. Not necessarily. You know, if you get out there and you notice the fan motor spinning a little slow, your coil is real dirty, or your fan motor's not working at all, then that's where we start. But we'll jump out here and see what we get into next, and I'll see you next time.